So thank you for waiting a little bit while we got this class set up. Over the weekend, I read all of your exercise 0 pieces where you told me a little bit about what you were doing. And on the basis of reading that, I realized that we've got quite a few students here who know a lot about GIS. And there's a fairly big range in skills. So I thought it'd be good to try and actually get some discussion and going about it. So that was also the plan for today. So that's why I went and actually recorded those pieces and encourage you to watch them. And I'm sorry I didn't give you a lot of advance warning, but maybe we can have a sort of quick go around as how many of you actually got to watch the recordings? Everybody here? Everybody remotely, did you all get to watch the recordings?
Yeah, I did.
Yeah.
Yeah. Yeah.
Great. So then we can go with a sort of true flipped classroom model and see if there's questions. So I guess you will have seen that I had this 3-page overview synopsis, which hopefully you read. The slides, and probably I'll bring the slides to the front because I might use them in answering questions. And perhaps we should first just consider questions on the first part, which is effectively the overview of spatial analysis and the way that raster information is represented, which was these slides from number 1 going through till number 16. So who can tell me what the difference between a floating point raster is and an integer valued raster? And maybe I'll see if I can arrange the screen so that I can also look at your names and pick on folks.
Floating point.
Is it that floating point is able to go places beyond the decimal, whereas an integer is just 1 to 100?
Essentially, yes. So a floating point raster would mean that you can have any real number on the grid cells, and an integer raster, you have, yeah, it's just an integer valued number on the grid cells. And I could actually maybe open up ArcGIS and we could see there's another important difference between floating point and integers. And that's to do with the sort of information that you might put in the integer valued ones.
Wouldn't you put discrete data in sort of an integer and then you'd use continuous for floating points?
Right, so discrete data, what do you mean by discrete data? Or recap what you mean by discrete data.
I guess I was more thinking, yeah, I was just thinking that continuous if you didn't, yeah, maybe I'm not.
Well, no, you're on the right track. So floating point is what I've got shown on the screen here. This next slide is discrete objects represented by these polygons. We would effectively convert from the polygon to the grid cells, but the numerical values might represent just, for example, number 1 might represent this green area, the number 2 might represent this yellow area, number 3 the blue, but then you have an opportunity to, as part of the data structure, also assign attributes to say what the numbers actually mean. So if we go on to this slide here, there's a value attribute table. So while you've got the integer values, you can then have a table that has even text information in it, such as, in this case, forest land, wetland, cropland, area, and you might have some numerical code. The numerical code that's shown there doesn't mean a lot immediately, but if, for example, this was from the National Land Cover data set, there's codes that are commonly used. And I think I touched on the National Land Cover data set and the coding in the first lecture. Okay. Any other questions related to the first part of this this lecture? And I guess I would also encourage you, especially for those remotely, when you speak up, just say who you are so that we can start getting to know each other.
Hi, I'm Marissa from Indiana. What would be the benefit of using the categorical raster data as opposed to using just a polygon or a shapefile? If they both just denote area, I guess.
Sometimes you can do an analysis with a grid that you may not be able to do with a polygon. Sometimes, well, maybe you want to be doing a raster analysis, perhaps a calculation of infiltration, and perhaps one of the pieces of information is soil type, and that's categorical data, but you need to figure out what the soil type is for each grid cell so that you can calculate the infiltration. Maybe you've got other information that's real valued at those grid cells. So a common function that we use is to convert from feature to raster to effectively set the data up for that sort of calculation. There is a quip that some of the sort of older GIS people say, and that's vectors correct and raster is faster. The idea being that the vector, the polygon feature type approach can represent polygons very precisely, and you've got a better representation. And the raster representation, depending on how small or big it is typically maybe faster, but it all depends a little bit on this issue here. If you've got really fine grid cells, you've got small file sizes, coarse grid cells. I mean, you've got a lot of data, and it may actually be slower processing. And there was also early on in the development of GIS, some GIS systems focused on vector data, other GIS systems focused on raster data, and nowadays they all sort of have acknowledged that there's really a need for both, and the sort of competition over one versus the other as better has thankfully gone away.
Thank you.
Can anybody else think of any reasonable response to that question? It was, why would you ever use raster data if a vector gives you a better, more precise representation? I'm just looking for any other ideas, since some of you have worked with GIS quite a lot.
This is Josh Sturderman from UNR. Oftentimes you need a spatially distributed data set for input files for modeling, for example, like land surface modeling, where a vector would not give you the same spatial coverage that a raster could.
Right, so the vector might not cover the whole modeling domain. although hopefully it's got information for your whole modeling domain, else you're going to be making up data. But maybe if it's road, you might assume for that part of the model it's impervious, and then the rest of it is pervious or something like that. So what sort of models have you set up that makes you think of that answer?
Well, for my own research, I use variable infiltration capacity model, VIC, which is a semi-distributed large land surface model, and it requires a bunch of forcing data on the front end as input files before it can be run. And those are gridded products akin to a raster.
Okay. Anybody else?
This is Christina from USU. I have a question about raster generalization. And how do we know, or how can we find out what the raster generalization approach was for a given map?
Any thoughts from anybody? So there's two ways you can possibly do it. One is to go and dig into the help information, and you might dig deeper and deeper and deeper and see what's happening. The other you might actually have to do it experimentally. So you could find a data set that looks similar to this, and then just do the vector to the raster. There is also a possibility, and we could look in the system for that and see if it may even give you an option. It may give you some sort of a generalization rule as one of the environment variables. That's not something that I've ever looked for, but there's a huge amount of settings with these tools, and I'm trying to think if I have any polygons handy that we could just try it on. But yeah, look for some of those tools. Any other thoughts? So I did also have a suggestion in terms of us getting to know each other. We could all go to Canvas and go to our profiles, and you should all have an account with a profile, and fill in your biography. So I just did that to fill in mine. I know each of you wrote a little bit about yourself in what you handed in the homework to me, but rather than, I mean, I didn't want to necessarily expose that to everybody without you being comfortable with it, but you can each go to this profile and say whatever you want to about yourself. And then when we're in the courses, you should be able to go to the people, and I see a little bit more information than you do. For example, I see the various identifiers, which is not actually all that meaningful, and your role, which everybody's a student. But I can, for example, click on CUAHSI here, and this is different. I don't know why is it not okay. Why is it not opening? Okay, there it pops up, and it says that there's a missing assignment, and that's because I think I wasn't actually assigning grades for that first assignment. But I think if you've got biography information filled in, it should say more. Okay, so if we click on Ainsley, there it is. Ainsley hasn't added a bio. But we could go to Lindsay. Why does it sometimes open this mode? I don't know. Let me go into the student view. So this will be how you guys see the class. So if I go to people, and there it is. So you should then see, if you each add your bio, then we'll be able to learn a bit more about each other. I would also encourage discussions. So we could actually go into discussions. And here we already have one discussion that Colin thankfully posted about this new hydrography data set publication. But if you have some interesting ideas that you have perhaps related to one of the assignments or lectures, just start a discussion about it and share it with others. So let me get back to, maybe we should move on and discuss the second part of the lecture, which was the part to do with map algebra and raster calculation. So who knew in advance how what ArcGIS would do in this situation where the grids were not aligned? Probably nobody. How many rasters do you think, how many calculations do you think the world has done where the users have just done this raster plus that raster minus that raster to do something, and they haven't thought about how the cell sizes may be different and what's going on? I think there's probably a lot out there, and it worries me a little bit on some of the decisions that might be getting made without having thought those things through. That's the reason why I went through this calculation. But anyway, what are your thoughts?
It's Lindsay here at USU. I was wondering if this that we're talking about on this slide is the same as orthogonality, or rasters being orthogonal. I've heard that in some of my past classes, and I was just wondering, is there a difference, a slight difference, or?
I'm not sure what you mean by raster being orthogonal.
It was something to do with the cells lining up.
Oh, so maybe there's a term somewhere that says that if the cells all line up, then the rasters would be orthogonal. It's not something that I've heard before. Has anybody else heard that term, or does anybody else know anything on that? Well, I mean, I've heard the term orthogonal. Orthogonal usually means perpendicular or at right angles, or it could mean that the rows and the columns are perpendicular to each other, but I think all rasters are like that. There may be some data structures that's not the case. I know you can construct a netcdf file that has the rows and columns not necessarily orthogonal, but rasters and GIS have, for the longest time, and a lot of the systems will actually even limit them to being square. You can actually get rectangular cells sometimes, but the vast majority are all limited to be square. And there's some writing that says a raster has to be square. And I think if you use the ESRI format raster, it has to be square. But I think if you use a GeoTIFF file or some other image file, it might admit rectangular cells. Okay. Any other thoughts on this raster calculation part?
Yeah, question here. Brent from San Diego State.
Hey, Brent, go ahead.
All right, going back to what she just said, maybe depending on how the raster is formatted, say, for example, you clip it to a watershed and the raster has a different resolution, maybe the amount of squares won't necessarily align. Probably, maybe that's.
Right. We could also, of course, ask Dr. Google. Let's see. Wonder what the raster concurrency nightmare in ArcGIS. And this is actually, looks like, Joe Wheaton is a faculty member in watershed sciences here at Utah State. So, well, you should find out and tell us next class. Because he's apparently written a paper about it, which has a slide set, problems with ignoring what ArcGIS does, why it's so hard to fix. And so I guess he's pointing out, so he's calling an orthogonal raster as ones that share exactly the same cell size. And pointing out that, well, here's an issue. You may even have rasters that might be in a different projection, so they may be differently aligned, and then the map algebra would be questionable. So he said here that the rasters need to actually be compatible. The code will work without it being compatible or concurrent, and it'll just do some sort of resampling. And I guess I'm saying as long as you understand and are happy with that resampling, you might have to use it. Or you can use the resample tool to get them to be concurrent and use the various snapping options. Okay. Anything else? So we could look at so the scale triplet. Anybody want to summarize for me what they thought of the scale triplet? This is not something that's typical in GIS. And you'll see that the examples are mentioned in terms of length and time. So since I'm looking at names here, I happen to be seeing Jake. Do you want to tell me the difference between spacing and support? Maybe Jake's not listening. Or somebody else?
This is Connor at USU, and my understanding of spacing is how far apart the different points are from each other, whereas support is how large of an area that individual point is representing.
So if you're looking at a grid, what's its spacing and what's its support? So you're looking at that. We could probably argue that the spacing is 150 meters, but we don't know what the support is really. And what the support is will get us back to questions of raster sampling. Values are average for the cells, where the support would be the size of the cell, or the values are samples at the centers, which the support might be a whole lot smaller. Could be a point, infinitesimal. It's hard to think of really being infinitesimal in terms of support, but there's always some sort of size associated with what it is that you're measuring, but it could be a lot smaller than the cell size, or it might even be larger than the cell size. If for example, you've got something like elevation data that you've calculated based on perhaps some satellite imagery that has pixels that are 50 to 100 meters, and then you decide through the marvels of GIS, oh, I'm going to interpolate this down to 5-meter resolution. Now I've suddenly got a high resolution digital elevation model. Well, it hasn't really, you've got a whole lot more data, but you haven't created more information. So the support could be larger than the spacing in that case. So any other thoughts on that raster calculation bit before I move on to the next section?
I had a question. It's Emma from Michigan State. I wanted to know when you would use the resample technique that you went over in the video as opposed to the raster calculation.
I would probably use the resample technique when I wanted to control how the resampling was done. I think I don't think the raster calculation has as many options to specify in terms of interpolation. I don't think you could necessarily do bilinear and cubic, whereas you could do that in the resampling. But it might be worth looking inside the software and checking out on that, because I'm not 100% sure that that's the case. So here's where I had the, okay, I guess I didn't keep the project, but say I'm going to add this. Anybody else have any thoughts on that while we're waiting for ArcGIS to load these 9 plus 4 data points? You wouldn't think it took so long to load 13 data points. Okay, so there, let's zoom to those layers. So if I was going to say do the raster calculator, so now you notice that there's actually 2 versions of the raster calculator. One is part of image analyst and one is part of spatial analyst. That just depends on the sort of licensing that you've got, I think. I always use a spatial analyst one because image analyst I haven't always had access to. But let's say we're doing precipitation minus infiltration, and we're outputting this into precipitation test, say a TIFF file. Now let's see what environmental options we have. We can specify the cell size to be the same as, say, the infiltration layer, which is 3 by 3. We can do snapping to be the same as infiltration. But I don't think we've got an option to do linear interpolation here. At least I'm not seeing it. There's a cell projection, preserve resolution, convert units, center of extent, mask. So there isn't an option to do interpolation. So when I do this calculation, it's just going to presumably use the nearest neighbor approach. And if I run it, it should give me a result having done that nearest neighbor approach. But if I wanted to do the resample tool, so now I've got, I can specify, say, the precipitation is what I'm going to resample. It's got a cell size of 150, but when I specify the output cell size, same as infiltration, now I've got resampling technique. So I can actually choose amongst those. So that's why I would use resample, because I actually want to control it to, say, do a bilinear interpolation, which would mean that I'm interpreting these 150 meter cell size precipitation values as values at the center of the grid cells. And when I want to go to a finer set of grid cells, I'm going to effectively do a bilinear interpolation between those center points to come up with the finer grid values, or whichever method I happen to pick here. So I think if you just do the calculation immediately, it's effectively assuming the nearest neighbor approach.
So for that first one, how would it do nearest neighbor for like the center grid when no particular of the big grids is nearest to it, they're all equal distant?
I think it'll pick at random. Well, effectively, it'll pick the nearest in according to the numerical precision. So, which is, for your purposes, probably random, because when you look at the sort of 5th and 6th decimal point and the way it's represented in the computer, it'll pick one. But these are good questions, and I'm hoping it makes you think about, as you're doing this analysis, what it's actually doing, because I think it's important to know what it's doing.
This is B. Gordon at UNR, and I have a question. I guess one question is, I wasn't totally clear on how the resampling would be different for like categorical versus, I guess, integer data or discrete data. And I think the other question I had is how much we should know before doing any of these calculations. Like if we're just sort of a casual user of GIS, how much we should be looking into each of, all the resampling techniques and know about that before just kind of doing any of the processing.
Okay, so the casual user question is maybe easiest to answer. I mean, I think you need to have a sense of how much it's going to matter to whatever decision you're making or something like that. And for a lot of things, it won't matter a lot. So just being a casual user and accepting the defaults is going to get you an answer that's often good enough to base a decision on. So you may not have to worry about all of these things. In terms of how it'll do things for a categorical or a floating point data, let's actually explore that a little bit. So I'm just going to remind myself what these numerical values were. Well, let me go and change the precipitation so that I had put this 3.1 so that it got interpreted as floating point, but let me go and see if I can go and, what was I calling this? So let's have a new one, and let's just make it 3, and let me save this as precipitation integer, and let me now add the precipitation integer value. And so now let's see if I do resample of precip int. It still gives me all of those choices. And well, so let me do I'll do a bilinear sample on the precip int, and we'll get a result. And if I let me export the precip int to say a TIFF file, and let's just leave the defaults all the way they are. Well, symbology. If I tell it the symbology, rather than I want it to be discrete, I want it to be, say, unique values. It's going to say, do you want to compute unique values? And now it's created for me. Well, there's a way to get it to create an attribute table. And when you've got discrete values, you can use an attribute table. I'm not exactly sure how to do that now. If you've got continuous values or floating point real values, you can't. So I feel like I mumbled around a little bit there, but hopefully I got the gist across.
No, that was really helpful.
Okay, anything more on raster calculator?
Hi, Marissa from Indiana again, Indiana University. How would you go about deciding which interpolation technique is best for the data that you have?
Think about what makes the most sense for effectively joining what are the dots. So you might think about if the dots are represented by this sort of figure, do you want to perhaps just do straight lines between the dots, which is effectively what bilinear does. If you do the cubic, that's effectively fitting some sort of a polynomial or some sort of a spline, and it's allowing some sort of a curvature to go between the dots. And that's going to allow you to, if you've got a data value there and a data value there, get a higher value in between. So in part, you've got to think, is your data such that if you have a data value there and a data value there, you want to allow the interpolation to come up with a value that's higher than or outside of the range of your actual data. Is that likely meaningful for your data or not? And it may depend on your data. If it's topography, it possibly is meaningful because you may not have hit the actual peak, and maybe it makes sense to go up, but doesn't always. So I don't know that there's a good answer all the time. But you definitely don't want a method that's doing this this wacky thing that's overfitting it.
Okay, thank you.
Okay. Anything else? Okay,
Go ahead.
This is Salma from USU. I have a question about the interpolation methods. Does Corriging method consider the Z factor, for example, the elevation, or it's just according to the X and Y?
So does the interpolation consider the Z factor? Well, I think normally what you're interpolating is the Z value. So you've got points in X and Y, and you've got a value of the quantity that is represented by the raster, which might be elevation, and you're interpolating, you're resampling to a different scale. It's going to adjust those Z values, fill in values in between.
Isn't it important for some parameters such as pressure or precipitation that we consider the elevation?
So you're asking about other covariables. So that is an important thing, especially for hydrologic models, climate models. So we have the person who is running Vic can maybe chime in. But you might have rainfall values, and we'll actually touch on this a little bit in the exercise that we do on Thursday. You might have rainfall values that are all measured in the valley, and you've got a mountain in between, and you know that there's an orographic effect, so that the rainfall in the mountain is more than what you would get directly interpolating based on the values measured in the valley. So you do have techniques, Kriging is one of them, where you can actually include a third variable as a covariate to try and use that with interpolation. Or sometimes with climate variables, often what's done is people bring some of their physical knowledge about the processes. For example, if it's temperature, there'll be an assumption that, oh, there's a lapse rate. And there'll be a use of the data that you've got to fit the lapse rate. And then you'll use that lapse rate directly. You might also assume that there's some sort of a relationship between precipitation and elevation. There's people who've made a career out of it. The PRISM group in Oregon the PRISM stands for Precipitation Regression on Independent Slopes Method. And they have come up with the idea that interpolating precipitation, you should consider elevation as well as slope and the direction of the slope. And they have developed a technique to exploit that. And then they've also brought a whole lot of other knowledge into that system, and they put out precipitation products that are pretty widely used. So anybody, especially the modelers, want to comment on that? The person who ran Vic? Are they still there?
Yeah, this is Josh, who ran Vic, or rather I'm using the Vic outputs.
Okay.
But I think it's a huge problem for the field of hydrology altogether, like very broadly, is actual empirical precipitation measurements, and figuring out how do we take something like a prism product, which is great, but pretty coarse spatial resolution, and then downscale that to the systems, the basins that we might care about. I think you're absolutely right in talking about assumptions and the adiabatic lapse rate or other physical processes, and using those to take the few data points that we do have and trying to extrapolate those across some orographic, topographic feature.
Right. So yeah. So there's people who have done a lot of research on that. I've actually had a graduate student write a paper on that, which you guys could find on my website if you want. Avi Sen Gupta. I guess what worries me is sometimes the choices on things like that may have more of an impact than the actual sort of models equations. And you think a whole lot about the models equations and whether you're representing infiltration right or whether you're representing runoff generation right. But the uncertainty associated with some of the inputs can overwhelm. But I guess that's what keeps us in business at some level. Anything else? Oh, okay. I should be paying attention to the chat. How do I get this to get bigger? Okay, so Jake was having trouble with audio. We couldn't hear him. He had a question about raster calculations. When performing calculations across different resolutions, is the calculated value the only preserved value, or are other attributes preserved? So I think if you're doing calculations on a raster that has a value attribute table, you will have to designate which of the columns in the attribute table you want to use, and it will only use that. So the other attributes won't necessarily come into that calculation. So that's answering Jake's question. I guess I've sort of jumped in the middle here. Then we had some questions from Bernaz. Is that how you say your name? Or Murzendal? Which is your first name? We also were having a hard time hearing her. Behat. Anyway, after resampling, do we have not a number value? Does the attribute table change? I think you could have not a numbers. You'd probably only inherit not a numbers from not a numbers being in the input. So there may be no data values, and you may be resampling, and the cells that get resampled from those no data values will probably also retain no data. And if you're doing bilinear interpolation, it may spread out a little bit, because that no data value may impact other grid cells. If you are going to an extent that's larger than your data, I suspect you'll get no data values outside of that. But again, that's something that I would actually probably discover experimentally if it was important to me. And then what is one raster has a value and the other one has a no data? I think you'll get a no data. If you have one raster with a value and the other with no data, the answer is usually no data. And I've actually, even also if you do a divide by 0, the answer is often no data. And I sometimes use that as a trick to mask things out. You can have 1s and 0s where 1's the area that you want, 0's not. If you do a multiply, you end up with just sort of zeroing the values. But if you do a divide by that 1 and 0 grid, you end up putting no data outside of your area. So that's a useful trick to think about. Okay, let's see, were there any other things I missed in the chat? Everybody was saying yes, they watched the video. And Yi Wang was wanting to be made the presenter. You guys shouldn't actually need to be made the presenter. If you have something you want to present, tell me, and then we can make you a presenter, but otherwise I'll mostly be on the screen. So you might be just pushing the button for doing that when you don't need to. Okay, let's move on and talk about slope. So, who knew that there were 3 ways of calculating slope? You knew there were 3. There are probably some other ways too. So now I'm dreading that somebody's going to ask me which one should I use where. Anybody got any thoughts as to why you might use the ArcGIS slope one versus, say, the direction of steepest descent slope? So my answer would be that I would use the ArcGIS slope if I'm doing something like calculating radiation, solar radiation, where there's a slope and an aspect, and that tells you the intensity of the sunlight when you know what the sun position is, and you can calculate the intensity of solar radiation, for example, evapotranspiration or snowmelt. I would use the other 2 methods if I'm dealing with the flow of water, because I think that from a grid cell, where the direction that water moves off a grid cell only depends on neighboring grid cells that are lower in elevation. It doesn't depend on how high some of the other neighbors are. So both the D8 and the D infinity approach sort of ignore the high neighbor values and they go only towards low neighbor values. And I think that makes them specifically customized for dealing with water, whereas the other slope is more general. If you're dealing with solar radiation, you probably want what the slope of the surface is, and you want to get your best calculation of that given all of the surrounding points. Now you might ask, well, what about something that's in between? Slope stability. Because maybe maybe the steepness of the slope matters. It's not only going down, but it's also the land above that might matter with slope stability. So then you have to, I guess, make a choice. And maybe you should fit your model and compare to data and see which one works best. Might be a good approach to use. Anybody else have any thoughts on the different slope methods? So Eduardo has a question. What if I'm trying to calculate changes in slope with time, like hill slope processes, for example? Well, I think that for that, you would probably want the slope values to, well, the grids to be congruent or concurrent so that they're in exactly the same place. And as long as you calculate slope using the same method both times, then you've got consistency. And I mean, if you're dealing with hill slope processes, or the hill slope processes you're interested in, perhaps downslope erosion, which is a sort of a water-driven type process, in which case you might consider the D8 or the D infinity slope, or is it something else? Anybody else with any thoughts on that? So part of the next assignment that's due on, that I'll give out on Thursday, and you'll have a week to do it, we'll have you do these calculations by hand. So make sure you know how to do them by hand. And if anything's not clear, now's a chance to ask. So nobody with any questions about slope? It does get pretty technically detailed, but if you just follow along with the slides, it's not too hard. We also have an opportunity to have you ask questions about the current homework, or the current exercise. That's due on Thursday, and I hope you guys have started it. I know sometimes students start it on Wednesday night if it's due on Thursday. But if you started or you've run into any difficulties, I guess any questions related to that or discussion related to the exercise?
This is B. Gordon at UNR. I have a random, it wasn't that big a problem, but with the projection of the Firefly map, in the tutorial, they talk about going into the properties and selecting the projection. And so when I opened that file, all I saw was source and metadata and citation. And I opened a couple of different base maps, but still couldn't see a way to actually change the projection of that.
This was in the ArcGIS example?
Yeah.
Okay.
So I was here, I think I might have it's user error, I'm sure, but it was interesting because I couldn't figure out, I could go to source and see what it was in, and it ended up being that the example that they had was different than the way that it was uploaded into my map. But yeah, I was curious about that.
So let me see if I've got this data in a state where, so which were you, I'm forgetting the step where we had to change projections.
Oh, so it's just it's just in the base map. It's really minor. So for the base map, they have us add the Firefly base map. And then they go through this whole sort of going from one projection to another for the base map. But when I loaded the base map, I didn't have the option to do what they were.
Okay, so do you want to guide me through that, or should I look it up on the help quickly?
Maybe I can just send it to you in an email if that's, and then just see if I did.
Well, it might be interesting. I mean, if you're having the problem, other students are possibly having it too. So if anybody has any insights, otherwise, we can, let me go to.
It's in the second frame that we put in, or in the frame of South America with sort of the.
So putting it at, like so looking from space.
Yeah, and so the map layer that I found that they suggested you find, I wasn't able to adjust it in the way that they said, which was fine because it was already in that format, but I didn't have the same options that they did, that they mentioned. So I thought that was maybe problematic.
Okay, so this was down here somewhere.
Yeah, I think it's like on the third one.
The Was the third or the fourth one?
I want to say, yeah, so it was the fourth one because you're doing the map layout, I believe.
I'm having trouble with all too many windows on my computer here. So let's go to okay, so we had a layout. So this particular project that I opened was not quite at that state, but I can still get there, I think. So if we insert a new layout, I think we were going with, well, I'll go with that. Then I was going to put a map frame that is, say, this, but then it said that we had to create a new map, did it? For that Firefly projection. Let's see. It was create an inset map. The content in the contents, expand the map frame. Right click on world imagery, choose copy. So we've got to add that. We had to do that. Where did we have to do something first?
Yeah, that was, I think it's the back, they have you choose it as the background.
As a base map. So, so this is in Portal Living Atlas button. So this is catalog, Portal Living Atlas, Firefly, and then which one was it? World Imagery Firefly.
Yep.
And what do we do with it? What did we have to do with it?
Put it in the frame.
Add it to the current map. Okay. I'm not sure that's what we were supposed to happen. Okay. Anyway, then where was the next bit that we had to deal with Firefly? Create an inset map. So this is where you were having trouble, was it? In the content, is this where you were having trouble?
I got it to work. What I was having trouble with was if you scroll down, if I remember right, it has you, I didn't have the option. Coordinate system didn't pop up for me in the map properties.
In the contents pane, double click map to open the map properties window. So, I think I have to be in a map, not in a layout. And I can double click that, and there should be coordinate systems there. If you're in layout, if you're looking at a layout, So if you're looking at layout, and if you look at a map frame, you just get this map frame property. So you might have to click on this, the map tab. So there's different tab objects that can appear in the middle here. One is the layout that you're working on, one is the map you're working on, and then there's also a catalog that shows you the files you're working with. And as you add new things, you could have a new layout or a new report or a new map, you get more tabs along here. So might it have been that, so this thing in there that's called Brazilian rainforest is called a map frame. And it's got properties which I get it like that, and one of them is coordinate system.
Yeah, definitely. I think I wasn't used to the different tabs, switching between that from ArcMap, and so I forgot that I was in layout, and so that makes a lot of sense.
Okay. All right. Anything else? Any other questions on the homework?
This is kind of minor, but on the first part of the watershed base map, do you want us to symbolize the HUC 12 watersheds separately, or is just that HUC 10 separation? So we have like the Little Bear Logan, and then there's like 4 HUC 10 and like 27 HUC 12s.
I was looking for something like what I had in here, where you use the HUC, you use colors for the HUC 10 and used borders for the HUC 12s. So this sort of effect, where did I eventually get to it? This sort of effect. So you can see the individual HUC 12s because they've got the gray borders, but you can see that there's 4 HUC 10s because they're each a different color. And then there's 1 HUC 8, which is the whole polygon. You don't need each of them to be an item in the legend, no. Yeah, so interesting how you put the legend together for that. I think you'd put the legend together and you'd call it HUC 12 polygons, and you'd have to indicate that the color depicts the HUC 10 level, something like that. It's the HUC 10 with the edges giving the HUC 12. So yeah, I mean, you can use a bit of creativity there. I wasn't going to be too picky, but if somebody can think of a good creative way to look at a legend, and I'll have 25 examples to look at and be able to see if there's any good suggestions that you guys come up with.
I guess the way that I kind of handled that, the legend issue, I guess I kind of cheated a little bit and made so there's a field already in like the HUC 10 when you create it that it says all other values. And so I just made the outline of all other values the same as like the outline for the other ones, and then labeled that HUC 12. So it just, I mean, it's not actually representing that, but if you just to make the legend, it labels it and it looks right. But that's not, I don't think it's technically correct, but it does give you an appropriate legend.
Okay. Well, that sounds pretty good. You could, of course, just have the 2 layers there. But it would do the same. If you have the 2 layers, you could have the HUC 10 labeled, and then you could put another layer on with the HUC 12s, just the edges, and maybe have a single color, which would achieve the same effect as we just heard. But it would be separated a little bit more. And whether you want it separated more or not is sort of up to you as to how you want to present it. Mostly, I just want you guys to learn how to put legends together and then think about presenting the information in a complete and clear way. And there's not only one way to do it. Okay, anything else?
Hi, this is Rachel from UW-Madison. I just wanted to confirm, is it all right if we do our own research site or a different area for part 1?
Yes, it's fine to do your own research site. It'll be a little bit harder because you'll have to dig for the data, but that's good. And I won't be able to know if your answers are right, but I've got an uncanny way of looking at numbers and seeing whether they're right or not. So, but I'm sure your numbers will be right.
Okay, thanks.
So I also want to hear from you guys, and you can either speak up now or send me email afterwards as to whether this sort of discussion approach, flipped classroom approach actually works, because it sort of doubles the time, because it means you actually have to spend the time watching, and then we spend the whole time discussing in class as well, whereas otherwise I would just be lecturing, but we wouldn't have any discussion, but you only get put through it once. So yeah, if anybody has any thoughts, you're welcome to speak up, or if you want to tell me that it's terrible and you want to be private about that, you can say that in email too.
My opinion, I think it's beneficial because I usually don't realize that I have questions until I've been able to like sit with the material for a minute. So, you know, just having you lecture, I wouldn't immediately know that I didn't understand something until I went home and tried to make it work, and it didn't. So I really like the flipped classroom style personally.
Well, we'll try it out. I'll see if I can keep myself ahead of preparing these things. It's a little bit hard sitting in my office lecturing at a computer with nobody giving me feedback, but sometimes I felt that the first class was kind of like that anyway, and I had a little bit too much material to try and get through, and I was rushing, so I may as well just do it and take the time. And you can probably also watch it at 120% speed and not lose anything, because sometimes my talking isn't. Yeah, you can speed somebody's talking up and get the same message across in a shorter time. Okay, well, if there's last chance for asking questions, otherwise I'll call it a wrap for today, and we'll see you on Thursday, and I'll email around the recording of my presentation of the exercise as soon as I've got it ready. Okay, well, thanks, and see you Thursday. Okay.
Thank you.
Bye.
Thank you.